Hello, welcome. Let's try to solve another Leetcode problem, 912, sort an array. So we are just giving an array nums and we want to sort it in n log n time. So the most popular way is quick sort and merge sort, but for this problem I would like to use merge sort. So the method of merge sort is like that. So for example, if we have an array 5, 2, 3, 1, so 5, 2, 3, 1. First of all, we're gonna divide the array into two parts. So what do we get? We get 5, 2, and 3, 1. And then we're gonna divide it into two parts for each of the subarray. So while we divide the array into two parts, I mean we're gonna use the midpoint. So we're gonna use m. It is in the middle of the array. So here in the middle of the array, we're gonna divide it into two parts. It's gonna be 5, 2, and this one, two parts. It's gonna be 1 and 3. Until the length of the array is 1 or 0. Maybe it is nothing from the right side. It is still okay. Yeah. So now, until we have 5 or 2, the array is 1 and 3. Until to this one, we just started to go back for the recursive function. So this is so there are two parts. So one is the merge and one is the sort. Yeah. So the merge sort part is we just divided into this kind of two parts and two parts until here, and then we started to merge. Yeah. So for 5 and 2, while we merge it, it's like merge two arrays in increasing order. So we're gonna make it to 2 and 5. Yeah. So we get a 2 and 5 array, and for the right side 1, 3. I'm sorry. This is 3 and this is 1. Yeah. This is 3 and this is 1. So we're gonna merge it. After merge, it's gonna become 1 and 3 in increasing order. So for the final result, we're gonna return this 2 and 5 with this 1 and 3. So we're gonna merge them together. So the final result gonna be 1, 2, 3, and 5. Yeah. So this gonna be the merge sort. It is a recursive function. Basically, it is a divide and conquer. First of all, we're gonna divide it until there's only the length of the array is only 1 or 0. And then we started to conquer it. And then we're gonna execute the merge. So merge, we're gonna return this result until we return the final result. Yeah. Now let's try to solve it. So we're gonna define two functions. A merge with the left side and the right side. They are both arrays. And we also need to define the merge sort function. So we're gonna define a merge sort. So inside it's gonna be nums, and I will give a pause. So the final return gonna be the merge sort with the nums. Yeah. Now let's start with the merge sort first. So as I said, if the length of the nums is less than and equal to 1, this means that the length of the nums can be 0 or 1. So we're gonna return this nums. Then we're gonna check the midpoint. It's gonna be length of the nums divided by 2. So we're gonna get an integer of a midpoint. Now we're gonna prepare a left and right. It means we're gonna divide it into two parts. So the left part gonna be the merge sort. It's gonna be the recursive function with nums to m, and the right part is gonna be the merge sort with nums m to the end. Yeah. So for this m or m plus 1, it is determined or us. So for me, I gonna prepare the left part is always smaller and equal than the right part. Yeah. Or you can decide it the right part will be more than equal to the left part. It is still okay. Now we need the final return. If we get the left and the right, we just need to merge them together. So we're gonna merge the left and the right. Yeah. Now we need to finish the merge function. So the merge function is just merge two sorted arrays. So the left is sorted and the right is sorted. So we need two pointers, two indexes. Let me use I and j. It's going to be 0 and 0. We need a result array. It's going to be the final result. Now we just need to check if I less than the length of the left array and j less than the length of the right array, so we can check it. So if left I less than right j, so we can put it inside the result for the left I, because left I is smaller, so I should plus equal to 1. So else, so result should append right j, and j should plus equal to 1. So after the while loop, we still need to check if there's something left behind at the left array, or there's something left behind at the right array. So we need to use the result dot extend the left part is starting from I, and similarly for the right part. Yeah, maybe it is empty. Maybe there's something. Yeah, but while we are writing this extend, maybe this left part has something. Yeah, maybe it is empty. Left and right, it is still okay. Maybe left has something, right is empty, or left is empty, right has something. So this kind of two lines of code checked everything, so we can use this extend. And finally, we just need to use the return for the result array. So this is going to be the entire code. So the time complexity is n log n, because for merge sort, yeah, basically it is a recursive tree. We merged, yeah, we divided and then we conquer it. So it depended on the depth of the tree, so it is a log n. And for each of the level of the tree, there will be n elements. So the time complexity is n log n. And the space complexity is also n log n, because we used the array. So for each of the level, it's gonna be the length of the array. Yeah, I mean in total it's gonna be length of the array, and the depth is log n, so the space complexity is also log n. Now let me try to run it to check. As you can see, it works. Now let me submit it to check if it can pass. Yeah, let me just copy. Maybe let me just copy the problem and try to submit it again. Maybe it's gonna be much faster. Or yeah, let me just submit it quickly. So from here, I'm gonna have a quick submit. Yeah, because there's some problem with this submission. Let me submit it from here. It's the same code. Yeah, I just want to have a test to check if it works. There's something wrong with this extend. Yeah, because I forget about it, the left and the right. Yeah, so the right should be right to j. So it should be right to j. Yeah, and here I also got something wrong. Oh, this is right. I don't know why from there it is copied wrong. Yeah, it should be like this. But now let me run it. Yeah, I cannot run it even. Yeah, I didn't copy the right thing. Let me just copy everything from here. Yeah, let me try this one. Maybe it works. Yeah, here it works. Let me try to submit it again to check if it works. Yeah, I don't know. It's just not the same code. Yeah, now as you can see, it's the same code from here, and it works. Yes, thank you for watching. See you next time.